Hello everyone, welcome to my YouTube channel Know About Embedded Systems. In today's video, we are going to develop a programming for GPIO using STM32 microcontroller. So without further delay, we will start the video. But before starting the video, if you are new here to my channel, kindly subscribe my YouTube channel, click on bell icon and share this video to your friends and colleagues. Let us start the video. GPIO programming for STM32 microcontroller. So guys, for this STM32 microcontroller programming, I'm going to use a Nucleo board. Currently, whatever you're seeing on the screen. So this is the board what I'm going to use, STM32 Nucleo. And I'm going to use the microcontroller STM32 F4 double series. F4 series. So this series of microcontroller I'm going to use with a Nucleo board. The Nucleo board, whatever you're seeing on the screen, this is the Nucleo board what I'm going to use for the programming. You can also buy this STM32 microcontroller in any one of the online. So before starting the video, you should also know one more important things: how many ports are available in your microcontroller, that is STM32 microcontroller. So in STM32 F4 microcontroller, this microcontroller, we have totally 5 ports are there actually, including H. There are actually 6 ports are there currently, whatever you're seeing on the screen. So we have a port in this microcontroller, STM32 microcontroller. The namings are given like with the English alphabets, like port A, port B, port C, port D and port E, and there is a one more thing is there that's called as port. So like this, in STM32 microcontroller, the port numbering they have done with the English characters, port A, B, C, D, E. Okay, the first point. Second point, each port, if you observe here, each port is capable of handling 16 pins. Port A is having port pin numbers from PE0 to PA15. Similar to that, if you look at port B, PB0 to PB15, then PC0 to PC15, PD0 to PD15, and PE0 to PE15. Like that, each port will have totally 16 port pins, and you can use whichever port you want for your configuration or your programming. Okay, this is the first and foremost thing you should know: how many ports available and how they are named, all those things. Diagram. This is the STM32 reference manual. So how to understand this STM32 reference manual, how to read and analyze and understand. So on this, I have already done one video. Please watch that, and I'll update that link in a iCard. So this is your STM32 block diagram. So currently, whatever I have explained about the ports, you can see here. So this is the, you can see here, this is the block diagram, and here you can see the ports are explained like this. So we have totally 5 plus 1, totally 6 ports available. So they have named like this: port A, port B, port C, port D, port E, and H. Port A to port E, all are 16 pin ports. They have named PA0 to PA15 and up to PA0 to PE0 to PE15. Like that, they have given the names and its nomenclature. And then we have PH, only 2 pins are there, PH0 and port H0 and port H1. Like this, they have defined. Second important thing, these ports are connected to the AHB bus. You can see here this block. What is this AHB bus? I'll tell you later. So you should also know in the microcontroller, once the microcontroller is designed, which peripheral is connected to which bus. If you see here, so this is actually AHB matrix. The currently whatever you're using, this is called AHB matrix. To this matrix, most of the peripherals are going to be connected, and also from this bus, again different types of bus will derive. So currently, from this point onwards, you can see here there are different buses are derived, that means connected. You can see here there is a AHB2 bus is there, there is a AHB1 bus is also, it is connected, and similar to that we have one more bus. Okay, here you can see this is called APB1. This is a AHB1, and from this AHB1, if you come down here, now you can see here, from this AHB1, it is subdivided into 2 more small buses. So bus is nothing but connecting terminals. Here you can see we have APB1 and we have APB2. So in one end we have APB, and another end you can see APB1 and APB2. Like this, different bus connectivity we should also understand before going to the programming. Okay, now if you go up, so I was discussing about ports here: port A, port B, port C, port D, and port E. These ports are connected to AHB1 bus, which is operating at 100 megahertz. Okay, why this is required, I'll tell you later. I hope at least where the port is connected, that information is clear. I hope. Ports are there. We have totally 5 plus 1 ports are there. So port A to port E. Now I'm going to develop a program to toggle an LED. I'm going to develop a GPIO program to toggle an LED, and this LED is connected to the port pin PA5. You can see here I'm showing here. So this is my port. Let us assume this is my port A5. To this port A5 there is one LED which is connected on the board. Okay, so which board I'm using, you should know. I'm going to use a Nucleo board here. The currently whatever you're seeing on the screen, this is the Nucleo board I'm going to use. Okay, so in this board there are two LEDs are there. One is a power supply LED is there, and one is a user LED is there. So we are going to use that user LED to toggle GPIO pins. Okay, yeah. Now, yeah, so this is how it is internally connected to the port A5 port pin. The LED is connected. In order to develop the coding, or in order to develop the programming for this PA5 toggling operation, we have to follow certain steps. 4 to 5 simple steps we have to follow in your GPIO programming. The first of all, so you can see here what is the first step. I'm going to explain here. The first step says that we have to enable clock to the port A. This is the first and foremost step I have to do, because in the microcontroller, when we turn on, initially there will be no power supply. Initially there will be no clock supply. That we have to enable. Okay, some microcontroller by default they will enable the clock to the GPIO, but some controllers will not do that. So usually that depends upon the microcontroller designer. So for that we have to understand, we have to read the user manual, we have to understand how the design or how the architecture is designed. Okay, in this microcontroller, initially when you turn on the power supply, the clock will not be supplied to any peripheral. We have to do the programming. Through the programming we have to enable the clock. That's the first point, whatever you're seeing on the screen. Enable is connected to the LED. Okay, that's why we have to use a port A, and where the LED is connected to PA5, nothing but port pin. So that's why we have to enable the clock to the port A. First point. Second point here, whatever you're seeing on the screen. So we have to configure GPIO port A5 port pin as an output port. Configure PA5 pin as an output port. How can I do that? There are different registers are there. In order to configure your mode operation, so we have to use this register, the currently whatever you're seeing now. So GPIO mode R. GPIO mode R is a register which is used to configure your pin operation, like how you want to configure, whether input port or output port, analog port, like that. I'll explain later. And even to enable the clock also, we have to use a register called as AHB1 ENR. AHB stands for Advanced High Peripheral Bus, ENR stands for enable. Okay, so we have to enable the clock. RCC stands for reset control clock. Okay, like that. I'll explain in detail later. So as of now, just try to understand only this much. We're going to use one special register to enable the clock, and we're going to use one register to enable the output mode. And in the next point, if you see here, I want to make it port A pin to high and port A5 to high and low. In order to do that, I have one more special register called as BSRR. GPIO underscore BSRR. This BSRR stands for bit set and reset. Okay, so all these things I'll explain with respect to datasheet later. Okay, so this is to set, and this is to clear. The same register we have to use to clear and set. So totally, in order to develop a simple toggle operation, we have to use 4 major things or 4 different registers. We have to use it, and we have to develop the code, and we will check the output. I hope theory part you are clear now. Now I'll go back to the user manual. So this is my user manual. Okay. So first of all, I would like to go with this one. What is the meaning of this RCC AHB 1 ENR? So before that, just I want to show you once more where my port A is connected. You can see here the port A. Our LED is connected. So LED is connected to PA5. PA stands for port A5. The LED is connected to PA5, that stands for port A5, and this port A is connected to, you can see here, the port A is connected to AHB1 bus, right? So we have to enable the clock. The first and foremost thing is we have to enable the clock. So we have to enable the clock to the AHB bus. Okay, so this AHB bus clock can be enabled using this one. You can see here whatever you're seeing, RCC, that stands for reset and clock control. From this module we have to enable the clock to the respective ports. Okay, so now that point I'm going to explain you what is this RCC and how can I enable your clock to the port A. So this is my user manual. Under this user manual, you can go to the section called as RCC. You can see here, this is my RCC section, reset and clock control section. You can expand here, and you can see here registers are there. If you want, you can read the explanation what they have given, reset clocks in detail explanation they have given, but I'm interested in RCC registers. You can click on RCC register, and there are many registers are there, but my interest is here. So RCC AHB1 register. You can click on this. You can see the name. So why I'm going for AHB1? I'm going to AHB1 because my peripherals are connected. My port A is connected to AHB1. That's the reason I'm going to AHB1. So you go to this register, and here you can see they have given the modules are the peripherals which are connected to AHB1. So to the AHB1 we have GPIO. You can see here GPIOA is there, B is there, GPIOA, GPIOB, GPIOC, GPIOD, then E, then H, then DMA, then we have CRC. Okay, like that, the peripherals which are connected to the AHB1, all the informations are available in this register configuration. I'm interested only in GPIO enable. Okay, so this nothing but bit 0. So when I use a bit 0, so this is going to enable the clock to GPIO A or port A. Okay, or you can say GPIO, anything is fine. So this bit, when you use, so this bit whatever you're seeing, that is going to enable clock to the port A. Okay, so I hope you are clear now. So I'll just copy this, and I'll create one macro. So this is my STM32 Cube IDE. So here I'm going to define one macro here, define. So GPIO A, one left shift of 0. Okay, so this is my macro I'm going to create for GPIO A. The role of mode R register, BSRR and BSR. How to set the port pin and how to clear the port pin, that point I will explain now. GPIO section. Here, yeah, you can see here, this is a GPIO section, GPIO number chapter, and here under this, you can see again, go to the register part. Under this register part, I will take you to the register called as mode R. You can see here GPIO port mode register. right? So I'll click on this. So now we will understand what it tells. You can see, so the name, you can see what he is telling, GPIO mode register. GPIO mode register. So that's what I have written in the slide, GPIO mode register, and followed by X, whatever you're seeing X here, this X is nothing but the port numbers. You can give port A, port B, port C, and goes on like that. This is the first thing you should know. Second thing, how this GPIO mode register works. So if you want to understand, you can come down here, this part you can see here, this part, and under this you can try to understand these statements. The GPIO port pins can be configured in 4 different modes: input mode, output mode, input mode, general purpose output mode, and alternate function mode, and then analog mode. So totally you can configure your GPIO port pins in 4 different operating mode. One is input, one is a general purpose output, and one is alternate mode, and then analog to 2 bits. You can see here for each port pin, this currently whatever you're seeing, this is for port 0, I mean 0th pin. Okay, similar to that, this is for port 1, pin number 1, and it goes on like that. Okay, so this is 1, this is 2, this is 3, and this is 4, and this is 5. So this bits, since the LED I told, no, so LED is connected to PA5, right? So I have to use bit number 10 and 11 bits. Bit fields I have to use 11 and 10, and I need to do a general purpose output port. Okay, how can I do that? So I'll make bit number 11 as 0 and bit number 10 as 1. So this configuration I have to make it. Okay, so bit number 10 and 11 I have to use, and bit number 11 should be 0, bit number 10 should be 1, and what I'll be using instead of that, I'll use 0x1. Okay, so 1 means it is 0, 1. Okay, I hope you are clear. This is called as a mode register. So this all. Now the last step, PA5, BSRR, and BSR. So how to set and clear, that point I'll take you. So go to the GPI section here, under this. So there is a register here, you can see. So this is the register name, GPIO port set and reset register. The name you can see, port set and reset register. Okay, so what it says, so it says like this: 0 to 15 bits, it is basically 32-bit register. 0 to 15 bits are used to set, you can see here, 0 to 15 are used to set it, and 16 to 31 we're going to use to clear. Very simple. It's 0 to 15 we're going to use set, and 16 to 31 we're going to clear. And you should also know the LED is connected to PA5, right? So LED is connected to PA5. PA5 it is connected. So this PA5 you need to go with port 5. You can see. So I have to use bit 5 and bit number 21. Bit field to set the, I have to use bit 5. To set the PA5 I have to use bit 5, and to clear it I have to use bit 21. Okay, so like this we have to develop the programming for your GPIO. Okay, so in the next video I'll be developing the programming, and I will show you a demonstration as well. So please watch next video as well. So if you feel this video is a informative video, click on like button and click on bell icon and share this videos to your friends and colleagues.